Okay. Now, I hope you will be able to see my. Now, see, are you able to?
Yes, ma'am.
Yes.
Yes,
So
ma'am.
let me start. Yes, yes. Okay. Thank you. Let me start with the start of this slide, beginning of the slide. So I'll be taking your basic electrical engineering. I am from EEE department, electrical and electronics engineering department. My name is Dr. Tamalika Chowdhury. So this subject, basic electrical, for this semester physics cycle of yours, D division I'll be taking, and the syllabus of the first module that I am going to begin today with you all, that I am sharing with you. Okay, so this is only module 1 that you can see here. The syllabus is written. Okay, so uh, is it visible now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay. So this is the first module we are going to study. DC circuits is the first part. It includes Ohm's law, Kirchhoff's law, analysis of the series parallel and series parallel circuits excited by independent voltage sources, power and energy. These are the DC circuit part. And module 1 also has AC fundamentals part, that is the fundamentals of AC circuit, that includes sine wave generation, frequency and various other numerical and definitions of different parameters like root mean square, average value, form factor. These are the things. I hope you are not means you don't know term wise these things, but we will get to know all these things, and it is very easier and interesting if you concentrate, and it will be good for you all also. Okay, so starting with the DC circuits part, I'll start not exactly I'll jump onto, I'll start with the very basic knowledge. I hope you all are familiar with the term called atom. Everyone has uh,
Yes, ma'am.
heard about, yes, yes, atom. So I'll start with the basic called atom. What is atom? Atom is the smallest part of any material. Okay, any material, any element's smallest part is atom. Means we know molecules as the smallest part, but molecules are composed of several atoms. So, starting with the atom part, we'll first explain what is atom and what is the things that an atom consists of. Means the elementary fundamentals that atom is made up of. Okay, so this is the structure of an atom. Everyone can see this.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes,
okay,
ma'am.
fine, fine.
Yes,
Okay.
ma'am.
So, this is the structure of an atom, and we all know that generally, I hope you all know that atoms are they made up of three things. What are they? They are electrons, protons, and neutrons. Okay. So, out of this electrons, protons, and neutrons, the neutron and proton part form the nucleus, which is inside. You can see nucleus written over here. So nucleus that is written there, it consists of protons and neutrons. Okay. So the outward shell part, the orbit circle that you can see, outward circle, that is electrons moving in respective orbits. So the outermost regions of the atom are called electron shells and contain the electrons which are negatively charged. Right? Everyone can understand? Any doubts till now?
No, ma'am.
Okay.
No, ma'am.
Yes. So this is the basic. So you see, this is nothing but physics actually that you have already studied. So I'm starting from that basic only. So our electrical engineering starts with this thing called electron that is moving outwards. Okay. So the electron that is moving outwards, that is the source of our electric current or the respective parameters called voltage and everything, resistance, that we will come to know. So what is that thing that leads to electric current from this small thing called electron of an atom? We will see that this electron moves around this orbit, right? So when the electron moves, this movement of electron causes something called, we can say that it consists of charge. We already know that this atom is made up of this neutron, proton, electron, out of which the proton is positively charged and the electron is negatively charged. Neutron has no charge, right? So this proton thing inside the shell, inside the nucleus, you can see that is our positive charge, and the one which is revolving the electron, that is the negative charge. Okay, so among the positive charge and the negative charge, if any one of them, if any one of them is removed or added, right, then it forms something called charge. The atom gets charged. For example, I'm just telling you, from the nucleus it is very difficult to move the neutron or proton. Means in the nucleus the neutron and proton cannot be removed because it has a strong binding energy, but the electron that you can see outwards, that moves or that can be added to an atom, right? So this thing called the total means the charge, what I am saying now, I will move on to what charge is. Okay, I hope everyone is getting everything for the first class, basic one.
Yes, ma'am.
Okay.
Yes, ma'am.
And I am audible, my voice is full volume, I hope.
Yes, ma'am.
Yes, ma'am.
Okay. So now we will move on to the electron movement and how charge happens, means the basic concept of charge. See, this is the concept of electric charge. What is charge? The total deficiency or addition of excess electrons in an atom is called as charge. If anyone doesn't understand in English words, I can explain in Hindi. I hope Hindi will be accessible to all of you. Okay, so I can explain in Hindi as well if you want. Just let me know. Okay. So the total deficiency or addition of excess electrons means if an electron is added or if an electron is removed, then that atom gets charged. Okay. So addition of electrons or removal of electrons, addition or removal, any one of them can cause an atom to get charged. Okay. So this is what it is defined in this good words. जो definition है, this definition is the total deficiency means कम हो जाना and addition या ज़्यादा हो जाना of excess electrons is actually in an atom is called as charge, and the atom is said to be charged. Okay. So this was about it, the charge part. Now, what are charged atoms called? If an atom gets charged, for example, positive or negative, मतलब इलेक्ट्रॉन ही वो है जिसका मूवमेंट हो सकता है. सो इफ इलेक्ट्रॉन इज रिमूव्ड और इलेक्ट्रॉन इज एडेड, उसको हम चार्ज्ड एटम और आयन कहते हैं. ओके, सो चार्ज्ड एटम्स आर नोन एज आयंस. नाउ if by any means, okay, if by any means an electron is removed, अगर एक इलेक्ट्रॉन रिमूव कर दिया, it loses the means it loses its negative charge. Negative charge जो एटम को बैलेंस करता था वो चला गया, so it becomes positively charged and it is known as cation. Now if an excess electron is added to an atom, then it becomes negatively charged and it is called as anion. So anion and cation, okay, cation तब फॉर्म करता है जब एटम पॉजिटिवली चार्ज होता है उसको कैटायन बोलते हैं, और जब नेगेटिवली चार्ज हो जाता है मींस इलेक्ट्रॉन ऐड होता है, then negatively charge hota hai, that is called anion. Okay, so anion and cation I hope you are familiar with now. Okay, the basic concept of electric charge, this was all about it. Okay, now we will just move on to electromotive force and current. Now see, hope everyone is able to see it, the slide. It is visible now?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
ओके ओके, अभी क्या है जो इलेक्ट्रॉन्स के बारे में बोल रहे हैं, इलेक्ट्रॉन्स अगर मूव करे, मूवमेंट हैपेंस, then that is the origin of electric current. Electric current is nothing but movement of electrons. Okay, so first thing that we will study here is now the electromotive force. What is that? Electromotive force is an electrical effort to drift the free electrons in one particular direction in a conductor. That is called as electromotive force or EMF, right? So this EMF is the effort that is required to drift or pull the free electrons in one specific direction in a conductor. Now ये कैसे होता है? You see, this can happen, this electrical effort that is put, that can happen by externally putting a electrical cell in charge. Means first of all, this EMF means electromotive force, it is measured in volts. Means इसका unit है volt. Electromotive force और EMF का unit है volt, same as voltage. So this electrical effort, such an electrical effort can be anything. जो electrical effort के बारे में बोल रहे हैं, that drifts or pulls the electrons, उसको हम कैसे connect करें? It can be anything by electrical cell that is connected across two ends of a conductor, and this direction of pull, मतलब जिधर pull करेंगे, this direction depends on how the external electrical effort is applied to the conductor. Okay, so till now anyone has any confusion, any questions or doubts?
No, ma'am.
Because I am starting with very basic thing. Hope you have already studied this. Still I'm basic concept wise I want to be clear. Okay, so this is how, what is the origin of electric current is. Now how this EMF is generated or how this external effort is put, just see this figure. This is a conductor. That bar that is shown there upwards, you can see that bar has inside it plus signs and dot minus signs. So you see plus signs are the positive ones and minus signs are the negative ones. Now if we apply the force, okay, then we see that the electron starts moving, and for the electrons are moving means the flow of electrons happen from negative to positive end. Negative to positive end the electrons flow, and the conventional direction of current is positive to negative, just the opposite. Electrons flow from negative to positive and current flows from positive to negative. Everyone just this is basic thing. Okay, whenever you see such a structure that a battery or electrical cell is connected across two ends of a conductor, then the direction of current that happens to be there, electrons flow करता है negative to positive से obviously, but the current flows from positive to negative, just the opposite direction. Flow of electrons जिस direction में होंगे, current उसकी opposite direction में flow करेगी. Okay, so this is the general picture. I have also written sign wise, it is noted there that the direction of conventional current is opposite to the direction of the flow of electrons. Okay, so you see I've written also, but still I'm explaining you that when any free electron, see the picture and you understand. Okay, when any free electron gets dragged, means pulled, कोई भी electron gets pulled from positive, okay, from an atom, it becomes positively charged ion. That is shown in plus 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 sign. You see. Now such positive ion drags a free electron from the next atom, because atoms are very closely spaced, एक के बाद एक आता है atoms inside the conductor, very closely spaced. So once एक atom positive charge हो गया, so it pulls the free electron from the next one, neighbor, पास में ही जो है उसका इलेक्ट्रॉन वो खींचता है. So this process repeats from atom to atom, okay, along the conductor. So this movement of or flow of electrons from negative to positive of the cell externally through the conductor, मतलब कंडक्टर के बाहर जो मूवमेंट हो रहा है, that is the electric current that we cannot see, but we obviously we can feel, but in that case shock may be given to us. So externally through the conductor across which the cell is connected is called the electric current. So this movement or flow of electrons from negative to positive of the cell externally through the conductor across which the cell is connected is called the electric current. Okay, so this is all about our electric current. I hope till now everything was clear to you.
Yes, ma'am.
Yes, ma'am.
Very
Yes,
good.
ma'am.
Very
Yes,
good.
ma'am.
If this is clear, I can proceed further actually. So this was all about the basic thing. Okay, the basic knowledge that is required for starting the basic electrical engineering. Now we know that what is charge and what is current. What is charge and what is current, that we know. Now this relation between charge and current is important for now. Means the current, electric current that we say is nothing but it can be defined as the rate of flow of the charge. जो charge है उसका rate of flow means time के हिसाब से rate of flow. Means अगर charge q है, for example if we write charge as q, then q by time is current. Means rate of flow of charge in an electric circuit or in any medium in which the charges are subjected to an external electrical field. कोई भी charge को अगर external electric field के ऊपर दिया जाए, then
Ma'am.
the rate of flow. Yes, yes.
Ma'am, I can't understand Hindi. Ma'am.
Okay, English is comfortable.
Yes, ma'am.
Okay, okay, very good. I thought that some people may be understanding Hindi also. Okay, no issues. So, the rate of flow of charge in an electric circuit or in any medium in which charges are subjected to are known as the electric current. So, basically, I is represented as the current. Let me show you. Let me just stop presenting and show you something. Am I audible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, okay,
Yes.
okay, okay, fine. So I'm going to show you now some of my notes. Actually, I'll explain with the help of that about the relation between charge and current. Okay. So let me start presenting again. So this is about the relation between charge and current. Everyone visible? Everyone can see this?
Yes, ma'am.
Yes, ma'am.
Oh, okay. Don't worry, I'll give you all the notes and everything that is explained in the class. Each and every bit you can understand if you read and go through it. Still, I'll explain first. See, the relation between charge and current. Mathematically, I is current. We represent I by current. You see, it is written that I is the average current flowing, Q is the total charge transferred, and T is the time required for the transfer of charge. Okay, so current can be defined as the rate of flow of charge in an electric circuit or in any medium in which the charges are subjected to an external electric field. Okay, now this I, which is the current given in amperes, we define ampere. Ampere is the unit of current. Okay, ampere is the unit of current. Q or the charge unit is coulomb, and T is time, that may be in seconds. Here it is obviously given in seconds. So we have different units. So coulomb by second or coulomb by minute can be said as current given in amperes. So ampere is basically equals to coulomb by divided by time, any second or minute. Okay, so 1 ampere we will define first. What is 1 ampere? 1 ampere is said to be a current of 1 ampere is said to be flowing in the conductor when a charge of 1 coulomb is passing through any given point on it in 1 second. Okay, so coulomb per second is ampere or current, electric current. So that is the relation between electric charge and electric current. Clear for everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Means
Yes, ma'am.
I thought of giving a problem sum, but it would be too early for the first class, so I didn't get any sum for you. It will be eventually basic electrical has several problem sums, but basic concept first, then problem sum. Okay, so I hope this is very clear. I'll move on to the next thing, which is called the electric potential or potential difference. Electric potential and potential difference. Have you heard about anyone potential difference and electric potential? Anyone?
Yes, ma'am.
Okay, very good. It will be helpful then. Yes, okay. Basics of physics. If you studied physics, this will be there. Okay. So electric potential and potential difference. Every charged particle has a tendency to work. That means to attract or to repel. Now, this ability. Can someone mute, please? Someone is not unmuted. Has unmuted. Please mute. Yeah. Thank you. So, electric potential and potential difference is nothing but what is the ability of that particle, okay, to do the work. That is called electric potential, nothing else. Means the ability of that particle to do work. How much work can that particle do? That is our electric potential, the potential of that particle, of that charged particle to do the work. Okay, so every charged particle has this tendency to do work. Work means what? To attract or to repel. Okay, to attract or to repel. That is called our work in case of this charged particle. That is the work that they do. So every charged particle has the tendency to do work, which is to attract or to repel, and this ability of the charged particle to do work is called its electric potential. And now coming to the unit again, the unit of electric potential is again volt. Okay, you remember EMF, we told EMF unit is also volt, electric potential unit is also volt, but these two are not same. These two everyone actually yes, unit wise these are same. The EMF or electromotive force and electric potential unit wise is same, but there is difference. Everyone, anyone, difference between electric potential and electromotive force? Okay, fine, no issues. Just a basic thing I'm telling. Electromotive force में क्या था? EMF. It was the effort to drift, means someone is pulling it. Okay, a force is applied there, external, जो कि battery है. Battery or any electrical cell is present there. Okay, so that effort by that external cell to pull the electrons in a particular direction in the conductor, that is EMF. And electric potential is what? Electric potential is the ability to do the work, means it is always present whether the external force is given or not. Means charged particle, they already have the ability to do the work. That is termed as electric potential. Okay, but the unit of both of them is volt, because why? That is also an effort, this is also work, so work and energy unit is same, so that is why it is volt, right? So this is it, that every charged particle has a tendency to do work, that is to attract and repel, and this ability of a charged particle to do work is its electric potential. Okay, so the unit of electric potential is volt. Now coming to the mathematical representation, electric potential is equals to work done divided by charge. Okay, so work done divided by charge is equals to or given by W divided by Q. Work done we can represent as W, obviously. Work done is W and charge is Q. Okay, so this is our electric potential. Now, the electric potential at a point due to the charge is 1 volt. Now, this is the definition of 1 volt. Previously, we studied about ampere. What is 1 ampere? Now, this is 1 volt. What is 1 volt? The electric potential at a point to a charge is 1 volt if 1 joule of work is done. Joule is the unit of work. It is also the unit of heat, but work is also can be termed as 1 joule of work is done in bringing a unit positive charge from infinity to that point. Everyone is understanding? Any confusion, please ask.
No, ma'am.
No, ma'am.
Yes, please be clear from this very beginning, then it will be very helpful for me also to teach you. Okay, so this electric potential is nothing but electric potential of a point due to a charge, a random charge, okay, a charged particle. For that, the electric potential of 1 volt is the ability to do the work of 1 joule. 1 joule in bringing a unit positive charge of 1 coulomb from infinity to that point. Okay, so this is about our unit of electric potential, which is volt. Now, the last thing is the potential difference. What is potential difference? In electrical circuits, the flow of current is always from higher electric potential to lower electric potential. And the difference between electric potentials at any two given points in a circuit is known as potential difference. Means, I'm just explaining. See, this was the conductor in this picture I am telling. Suppose इस conductor का start and end. Start or end में whatever the starting point of the conductor is and the end of the conductor is, that starting and ending of that conductor. I am not marking here, just understand the starting and ending of the conductor. If marked as A and B, then the potential at A and the potential at B. The difference between the two potentials is called our potential difference. Okay, so nothing but the higher, always remember one thing, the flow of current is always from higher potential electric potential to lower electric potential. Just like think about water flow or any liquid flow. क्या होता है in liquid flow? From high to low it flows. Any liquid, any fluid from high to low means height wise, slope wise, any ground position wise. Suppose in a floor is placed and uske upar in that floor liquid is flowing. Imagine that to be current. Okay, so that floor is our potential. So from higher potential to lower potential, the slope of the flow higher to lower, that thing we call as potential, and the difference between higher potential to lower potential is known as potential difference. Okay, so this is the definition of potential difference, which is nothing but it is said that in electric circuits, flow of current is always from high potential, high electric potential to low electric potential. And the difference between the electric potentials at any two given points in a circuit is known as potential difference. Now, this is also called as voltage, V. Because see, potential, electric potential unit was volt. So obviously, the difference between two electric potentials means volt and volt. Obviously, its unit will be volt only, voltage. And this potential difference is called as voltage. Voltage between the 2 points that are measured in volts, and it is given as V. Okay, so to maintain the flow of electrons, that is the flow of current, there must be a potential difference. Dekho, if there is no potential difference, means the voltage between 2 points in a conductor is same, then no current will flow. Only current flows only when there is a potential difference between the 2 points, or there is a voltage, potential difference is the voltage, or there is a voltage existing between the 2 points. Okay, so this is about our potential difference. So today you came to know about the two things, very important two things, electric current and potential difference or voltage. So this is the basic needed for moving me into basic electrical engineering, and that is given by the two most important parameters, electric current and voltage. Always remember this basic thing of electric current and voltage. So I'll not take much time. Anyone has any questions?
No, ma'am.
No, ma'am.
It is clear to you all?
No,
This
ma'am.
first class, the basic class?
Yes, yes, ma'am.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
Ma'am.
Very nice, very nice. I
Yes,
hope
ma'am.
the response will also be good from now on. And total 40 are here now.
Excuse me, ma'am.
Yes, yes, please.
Ma'am, I just wanted to ask you about what books to get for this subject.
Yes, sure, sure. Yes, books. I'll suggest CL. Should I write it down?
Yes,
It will be easier for you, I think. So I'll just write down. I'm sharing my camera with you. Just showing the book, you will understand. I don't need to write then. I'll just show you the book itself. Everyone visible?
No, ma'am.
Is this visible?
No, ma'am.
No, ma'am.
Not visible?
Yes, ma'am.
Okay. Just see whether everyone respond. Whether anyone cannot see, then you tell me. This is the book. You can take a screenshot. You can write down the name. This CL Wadhwa you see written over here.
Yes,
CL
ma'am.
Wadhwa.
Yes, ma'am.
CL.
Yes,
Yes.
ma'am. Yes, ma'am.
Okay.
Yes,
CL
ma'am.
Wadhwa is the name of the author, and Basic Electrical Engineering is the name of the book.
Thank you, ma'am.
Okay. Very good. Fine.
Thank
Okay.
you,
Okay.
ma'am.
Okay. So I hope this class was effective for you all, the first one. Then next what we will move on to is our circuit, about circuit. The circuit thing, that is very basic thing. From there onwards, we will move on to DC circuits and AC circuits. Actually, whatever I taught you today is not exactly in the syllabus, but the concept wise, it is very important. Necessary concepts I want to clear first, then I'll move on to the syllabus wise. I don't want to rush. I want to go step by step for you all. Okay, so I think enough for today. For the first class, try to know about the roll number so that I can do the roll call for you all. I don't have the roll sheet as well, so I'll try to do the roll call, and that will be better, and the interaction will also get on well along. Okay, so I'll just end this class. Anyone has any doubt can put message in the group, or you have my number as well in the WhatsApp group. You can individually ask questions also if you feel here not to ask. Okay, so individually you have the number, you can message me in WhatsApp. Anything further needed, the notes, the books, everything, I can make you just communicate well. That's it. Okay. Thank you everyone for this class, for the participation.
Thank you,
See you.
ma'am.
Thank you,
Yeah.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yes.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay. So, end of this class. Thank you. I'm just putting an end to this meeting. You can leave as well.
Okay, ma'am.